Okay, this is lesson 71, translations. Remember, that is a form of transformations, such as reflection, rotation, and here we have translations. Okay, so remember, reflections were the flips, rotations were the turns, and what were the translations?
Where you like move it?
Okay, yes, you move it, but I wanted you to use the little SL here in the middle to help you remember. Do you remember what the SL stood for as kind of a clue or a hint word on what translations are? Nope, slides. You slide the figure. So that's what we're going to expound upon today. This first example says a square has vertices A11, B41, C44, and D14. So step 1 is to plot these on our coordinate graph over here to the right. So let's do that first. Let's graph carefully. Okay, so at 1, 1, we're going to plot a point there and we're going to label it A. At 4, 1, we're going to plot it and label it B. 4, 4 is where we have C. And 1, 4 is where we have D. So we plotted those points. Now we're going to, as best as we can, connect those dots to make the square. So that was step 1. It says here, find the coordinates of the vertices of the image of square ABCD after a translation of 5 units to the right. So we're going to start with A. Look up here. We have A. We're going to move 5 units to the right. We're going to plot our new point and we're going to title or label that A prime. So A apostrophe. Okay, I'm going to use a different color just so it stands out. So there's my A prime. Can you tell me where that's located?
6, 1.
Very good. 6, 1. Will you please do that same exact thing with the 3 other coordinates? Move them 5 units to the right, plot them, put prime, and put the ordered pair, the coordinate that goes with it.
You have to label A, B, C, D?
Yes, because then it shows the new location of where it's been translated. Where did it slide to?
Like this.
Can you check?
Yeah, perfect.
Can you check on it?
Yep, and I'll do it with you right now. Okay, so A prime, 6, 1. And then B prime, what'd you get?
9, 1.
Very good. That's also what I got. And then C prime,
9, 4.
9, 4. I agree. And then D prime.
6, 4.
Very good. Easy peasy. All right. So we did this step. Now let's read part B, where it says, show that the area of ABCD prime is equal to the area of ABCD. So ABCD is the pre-image. Let's look at the units within each of these and see if they are equal areas. What's the area for the pre-image? 9 units. And what about our translated image?
9.
Yes, so the areas are in fact equal.
So do you have to like write it out where it's like, well, I guess this isn't segment, but it would just be like ABCD equals 9 and then prime ABCD.
Perfect.
Okay.
Okay, moving down to the problem below, it says the vertices of triangle of a triangle are x is at -2, 0, y -2, -4, and z 1, -4. So please start by drawing this triangle on the coordinate graph and labeling each point. And do it very carefully. And when you're finished, look up here and see if yours matches mine. Okay, the directions say, find the image of triangle XYZ after the translation of this rule right here. I want you to notice something. +5 means that we're going to the right 5 because the x-axis is horizontal, so it's left-right, correct? And the y-axis is vertical, so it goes up-down. So this rule right here is trying to tell me that they want me to move 5 to the right and 4 up. What if this had been a -5?
5 down.
5 to the left.
5 to the left. What if this had been a -4?
4 down.
Yeah. So y'all understand how this works. All right. So 5 right and up 4. So we need to go 1, 2, 3, 4, 5. 1, 2, 3, 4. Plot my point. Label this x prime. And put the new coordinate.
Wait, Ms. Davis?
Yes?
Since the -2, 0, since those are the x and y, could we just plug in the x plus 5?
You
and x plus
absolutely
4?
could. So if you prefer to do it mathematically, you can plug those numbers in. But if you're more of a visual person and you have to actually see the move 5 to the right, up 4, then that might be better for you. Or if you really are a high achiever and you want to do both, just to make sure you got it right, that would be lovely.
So if I did that for x, then it should be 3, 4?
3, 4.
Right.
And I believe you're correct because if I move 5 to the right, up 4, that is in fact, I like to use different colors. Give me a second.
And you want us to find the coordinates for these?
Yes, please.
So then it should
Just
be,
to make a good habit out of it.
So then it should be this then?
3, 4. Yeah, you got that
3,
right.
4, and then 3, 0, 6, 0.
3, 0, and 6, 0. You got it.
Minimal method.
Is that what you're going for? And what were, you said 3, 0,
And then 6,
6, 0. And then be sure to
draw it?
connect those dots.
3, 0, 5, 0, 3, 4.
And the reason why you want to do that, especially with this question, Thomas, is because look at the directions. It says show the pre-image and image on the same coordinate grid.
Oh, yes.
So though you provided the coordinates for me, that wouldn't satisfy this question because they want you to show both of those triangles on the same grid. Make sense? Do you have questions?
They have to be written on the grid, is what you said?
Because of this direction right here, these instructions show the pre-image, which is right here, and the image, which is right here,
Okay, yeah.
on the same coordinate grid.
Okay, yeah, that makes sense. You don't have
Okay.
to, if I wrote those below, that's fine. I don't have to write them on the grid, A equals B.
Yeah, you can write it down there, but at minimum, I have to see both
yeah, I
triangles
have-
on there.
Yeah.
Okay, and don't forget your prime, your apostrophes, okay, because that tells me the image that was translated versus the one that was the original image. So don't forget those apostrophes. Okay,
What if we don't have the apostrophes?
Get points
then you get
off.
points taken off.
Like a lot?
Thomas, stop. Okay, so moving on, flip to the next page. Translations continued. So we have here, find the image of ABCD under the translation. We're sliding again. Vector 2, 3. This is no different than what we just talked about, where we're going to the right 2 and we're going up 3. They're just called vectors. Vectors are positioning. So vectors are related to translations, how something has been moved or translated or slid or moved over. Okay, so I want you to do the same exact thing. Take each of these points, A, B, C, and D. Move them to the right 2 and up 3. And then label them A prime, B prime, C prime, D prime. And connect your points to make the square that's been translated. 2 units to the right, 3 units up.
Like the speeder points?
So I got yes, 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 and yes.
And then draw it.
Correct.
Yeah. So will they write it in homework, like more like this, kind of the like vectors, or more like that, when they have the like x plus 5 and
They will have a variety.
interchange? Okay.
They'll ask it multiple ways. That's why I want to make sure you're comfortable and you're familiar with different types of ways that they will ask it.
Okay.
All right, Logan, will you tell me where A prime is located?
2, 3.
2, 3. I agree. Kellen, where's B prime?
3, 6.
3, 6. Let's see. Did you go over 2 and up 3? We should have landed right here, which is 2, 7. So double check that. Oh, I think, Logan, you said 2, 3?
Yes.
Okay. And then Harper, where's C prime?
6, 7.
Say it again.
6,7.
6, 7. Oh, that's, yeah, very good. C prime, 6, 7. That's C prime. And then Thomas, where's D prime?
6, 3.
6, 3 is D prime. Then y'all remember to connect those dots to make the square. There you go. That's the answer. Okay, moving on to the next question. It says a character in a new animated movie will move from the point 4, -5 first to the point 16, 3, then to the point 13, -2. The question asks, find the vectors the animators need to apply to the character to make these two translations. So let's start first with x. Remember, x is a horizontal line. We're going from 4 to 16 first. Do you see that? So we're going to mark that. 4 to 16 moves to the right. How many units?
16.
From
20.
4 to 16 is how many units?
12.
Yes, plus 12 because we went to the right 12. All right. And then y, the y-axis is a vertical axis, correct? So it's up, down. We're going from -5, y'all see that? To 3. So on our number line, we're going to go from -5 to 3, which is moving up how many units?
8.
So since it's up, we're going to do positive, and then there's 8 units in between. So positive 8. So our answer for this first movement is 12, comma 8. That's our answer for the first translation. Do you see here where it says then? So there's another movement. We're translating again, this time from 16:3 to 13-2. So we're going to do it again. Our x-axis is horizontal. We're going from 16 to 13. So we're going to the left. How many units?
3.
So that's a -3. Do y'all see why I put -3?
Because you're going to the left.
Very good. Make sure you caught that so you don't wonder later while you're doing your homework, like, how did she decide what would be what? Okay, our y, again, vertical line segment. We're going from what to what?
-2 to 3.
Say it the other way.
3 to -2.
Yeah, because it matters. See right here? We're going from here to here. 3, -2. So let me write this down. The 3 would be up here, wouldn't it? The -2 would be down here.
Mm-hmm.
So we're going from 3 to -2, which is down. Is down positive or negative? Negative. And by how many units?
5.
5. How should I write my vector?
-3.
-5.
Very good. -3, -5.
So that's your final answer?
Correct. So these two right here. It says find the vectors. So I did that. I found both vectors that the animators need to apply to the character to make these two translations. All right, questions before we move on to lesson 72. Okay. Tangents and circles, part 2. Let's start with the definitions. We have a common tangent, which is a tangent to 2 circles. Notice down here, we have external common tangents. See the 2 circles? And we have internal common tangents. So you'll notice, and I'll highlight these, external, internal. External is on the outside, makes sense. Internal is on the inside. But regardless, they're both tangents and both circles share them. Okay, let's look at this theorem down here where it says if 2 tangent segments are drawn to a circle from the same exterior point, then they are congruent. Do you see this exterior point right here? That's what they're talking about. So they're saying, watch here, that this is congruent to this, and this is congruent to this. So right away, can you tell me what x equals? 12. So over here where it says find the length of MQ, all I have to do is put the value of x, which y'all told me is 12, right here. So we're going to write 2 times 12 minus 10 equals what?
14.
14 is segment MQ. Make sense? Okay, moving on to the next definition. Right here, tangent circles. Tangent circles are coplanar circles that intersect at exactly one point. So that would be right here and right here. Do you see how the two circles touch at one point? Over here we have internally tangent circles, and over here we have externally tangent circles. This question here says, in the diagram, circle Q is tangent to circle M. See how they touch at one point? And segment NP, where are you? Right here, is tangent to circle Q. See circle Q? So we know that this is a right angle. I'm actually going to go ahead and write that in before I forget. We know that when a tangent line intersects with the radius, it makes a right angle. Okay, let me keep reading. The radius of circle Q is 5 centimeters. So let me stop and label. Circle Q has radius of 5. And the radius of circle M is 2 centimeters. So let's label both of those radiuses. Radii, 2 centimeters. Okay, here are my instructions. Find the what? Area. Find the area of triangle QNP to the nearest square centimeter. What's the formula for area of a triangle again?
Base times height divided by 2.
Yes, 1/2 base times height. Well, look up here. I have my base. I don't have my height. How do I find the height in order to solve for the area?
Pythagoras theorem.
Yes, Pythagorean theorem. What does this side measure?
9.
It does. It measures 9. So, use Pythagorean theorem, please, to find my height so that I can find the area by using 1/2 base times height.
Is this the answer?
For this right here, or for the final?
For the
answer?
final. Wait, when we
And
do
show
the,
your work, Thomas. Show me your where you
wait,
applied
when
height.
we do it, are we supposed to reduce it after we get it
Let me see.
from the Pythagorean? Because I didn't reduce it, but
Oh, I see
Okay.
what happened.
should we just...
You used the hypotenuse as your a squared b squared. Slow down. Guys, be careful. This is your hypotenuse. So when you're applying the Pythagorean theorem, keep that in mind. This is the c squared. Don't use this as a squared or b squared.
What you find the height? Base times height. Is this right?
Mm-mm.
So
Wait, is it this? Because then you do that. and you
You're
do
on the
that,
right track.
And then you...
Yep, keep going. What'd you
then-
get for your height? When you did Pythagorean theorem, what'd you get?
Up to 10.
Did you use this right here, the 9 as your c squared?
No.
I got 7.48.
For this?
The height.
Yes.
And I did that times 5, and I got 37.416. Divide that by 2,
got
which should be
10.
18.70.
and then round to the nearest square centimeter.
19 centimeters.
That's the answer. No, not really. 19 centimeters squared. It's area.
So
Right,
you
I
did
get
5
that.
squared plus
Here,
9.
I'll show you. So y'all all agreed that I should use Pythagorean theorem. 5 squared plus b squared equals c squared. So we have 25 plus b squared equals 81. Then we subtract 81 minus 25, we get 56. Then we take the square root of both sides, and b equals 7 point what?
5.
7.5?
Yes.
All right. Now we come over here where y'all told me the area is 1/2, base, which is 5, height, which is 7.5. Punch that into my nifty, dandy little calculator, and I get 18.75,
Yes.
which rounded to the nearest square centimeter is 19 centimeters squared. Where was your mistake?
I didn't round it. I didn't round the that.
Okay.
I put the 9 square as the b.
Mm-hmm.
Well, I did that too.
It's always important to identify where you made the mistake so you can learn from it. So you can prevent it from happening again. Okay. Go ahead and attempt these practice problems. I want to check them before you
The one for
leave.
Lesson 71 that I was confused on